Hello everyone, my name is Jeevan. Welcome to my project AI powered fashion recognition for smart shopping. So today I will demo how I built a deep learning pipeline on Kaggle notebook to classify 15 different types of clothing types like jeans, polos, jackets, dresses and more. So I have used a platform called Kaggle Notebook. Kaggle Notebook, and today in this demo we will see how I prepared and augmented the data all inside this Kaggle notebook, which is having free GPU environment. Also, we will see which model I have used to train and what tricks I have used to train its performance and improve its accuracy. And also, we will see the detailed evaluation of loss and accuracy curves. We will also see a confusion matrix and our F1 scores. Also, we will do a noise robustness test and a simple image based recommender also, like if we give an image, it has to give a different types of similar products. And also we will be testing our model with completely unseen images from internet. So let's get started. So this is the environment of Kaggle notebook. So on Kaggle notebook I have picked up GPU. I have become accelerator GPU T4 into 2, so my training will be faster. So here I have taken a class dataset. So in this class dataset I'm having 15 folders. So each folder is like will act like an individual class. So my images will live. So if we take here, so you can see the images, right? So my images will live in this folder. So each subfolder is one clothing type. So there are 15 different types of clothing type, and PyTorch can read this structure automatically. Now let's get into the code walkthrough. So here I have imported different kinds of libraries that I need for this. So first, coming to the data transformation. So here I have imported the torch vision, like to import the images from this data set. And also if we see, I have used different types of tricks here, like resizing it, cropping it, or flipping it. So the resizing is like zooming in and zooming out of image, flipping the images. And color jitter is like adding colors, different kinds of colors with different lights, different light settings. We are doing all these things because to improve our model. So here I have created two pipelines. One is training pipeline, another one is the validation pipeline. So in this, if you can see, I have used the resize, so it will make all the images to the same size. Then I have used random flip and the zitter. So this random flip and zitter will change the lighting and flip the picture, so the model will learn the different kinds of varieties. And also I have used the random erasing. So random erasing is like sometimes on an image, like if you put hand and if we take the picture and ask it to give similar items, still it should be able to validate that. So for that we have also given this random erasing. These all are like different kinds of tricks to train our model to become more efficient and accurate. Then if you see, I have so this whole data set is having 7,500 images. So I have divided this into 80 is to 20 ratio. That is, I have divided 6,000 images for training and 1,500 images for validation. So here you can see, I have taken all images and split 80% for training and 20% for validation. So validation images get the simpler transform, so I can fairly measure the performance. So I have did this section. Then coming to the model that I have chosen efficient net V2 model, because efficient net V2 model is the latest model that is available in the market. It is fast and it is accurate also because it has fewer calculations. And one more advantage is that it already comes with a pre-trained model, that is with an ImageNet. It comes, it is a big image data set. So it is having a good feature. You don't need to train from scratch. Already some millions of images that ImageNet data set is, it is trained with that ImageNet dataset. So I only changed its last layer. So it outputs the out 15 clothing categories. I did not disturb the existing model. I only used the last layer only. And next, I have also implemented the loss optimization. That is, I use the cross entropy loss. So this will give the smooth labeling and it will prevent the overconfidence. And then I have used the Adam optimizer. So this will adjust the weights and this will adjust the weights. Then I have used the cosine and annealing LR. So this will lower the learning rate of each epoch, and it will ensure that it will give a smooth learning. So we will get a better minimum. And then we can see this training loop. So one loop for the training and one is for validation. So this epoch is like you're training it, it is a training loop. That is this we use to train our model. So here I am running 15 epochs for my testing. So here we have two functions, right? One is for day training and one other is for validation. So what training will done is the training model will see all the training images and it will make predictions. It will calculate the loss and it will also update the weights. And what validation model will do is validation model it will see like if there are any unseen images that are there, it will measure the accuracy, and it will also print so here this function it will also print the training and validation accuracy for each epoch. Epoch is like the training like one training session. So these functions we wrote like in such a way that so for each training, no, it will give how much it is, for training how much accuracy and loss we are getting, and for validation how much accuracy and loss we are getting. Also after that we have written a code actually print out our loss and accuracy curves. So as you can see from the output, so for here I have run 15 epochs, and for each epoch you can see how much it has trained, and what is the loss and what is the accuracy. Validation also, how much loss and how much accuracy. If you can see from epoch 1 to epoch 15, so the training initially the accuracy was 0.48, but as we kept on it training, the accuracy has reached to 0.993, which is like 99%. Also if you look at the validation, initially it was like 70%, but when we kept on training, the accuracy level has reached to almost 80%. So if we look at the curves here, so here you're having a train loss. So the train loss is going down for each epoch. So which means this is a good sign, right? Because the loss is getting reduced. So this is like a good sign. Our model is working well. Also, if you see the validation loss, it got flattened. So this is also like this means like it is not more or less, but it the model is like behaving stable, and then we can improve more with more training. And also we have our accuracy curve also. Here in our training accuracy curve, if you see, it has climbed to 99% our training accuracy, and also our validation accuracy also, it has jumped to 80%. So this means that our model has actually learned all the data very well now. So next we have if we see our next output, we have the confusion matrix here. So in this confusion matrix is nothing but it will show like in our we have trained our model, no, with this data set. So in this data set, where exactly it is, I mean, how for each class, how much it is getting, the model is getting confused, it will show. Here we can see, so you can see this rows we will consider as true labels, and columns we will consider as predictions. So you can see, right? So rows is like validation and columns are like predictions. So here it is showing, it is having all the 15 classes here. So here you can see this bright squares, right? So this bright squares which are diagonal, they are the correct counts. So if you can see, it is able to predict the genes like most accurately, like 98% it is able to create it is able 98 times, it is 98 times, so 98% it is able to predict. But if you take example of Blazor, so if you see Blazor here, sometimes for Blazor you can see the number 17. So number 17 is falling to mantle. So 17 times it has mistakenly predicted Blazor as a mantle, right? Then we also are printing, we have this our F1 score table. So the F1 score table, it will give precision and recall for each class. So here in this F1 score you can see, right, if F1 score we are taking as a round of 1. If we take as round of 1, you can see here for denim jackets and for jeans, it is like it is giving high prediction, which means the model is very accurate for this. So if we give any input for jeans, or if we give any input for jackets, this model is like it is now very accurate. It will give the most accurate results. Even if we take any sample image from internet and if we give, then we can test it. Later in the later part we will test it and see. So it is giving this F1 score will give the percentage of the accuracy that a model can predict for each class. So that is also we are printing here, and then as our output. And then if we look forward in our code, we have also tested this feature. Like I have from this data set, like how much confident it is having, and how much accurately it can give the top. I mean, this output will get based on the accuracy and the validation. So here you are having the top three correct and incorrect outputs. So here we have given our test value as this Panjang, and it correctly predicted Panjang with a confidence of 94%. So this is correct. Even here also we have given input as hoodie, and output also it has predicted correctly as hoodie. Correct. Same with the denim. But if we sometimes this model is predicting wrong also. So here we are giving input as rock, but we got this as pending. Also here we have given input as mantle, but here we got something else. Right. So here we have we can see three different traits. T means true label, P means prediction, C means confidence. So this will help us where the model is behaving overconfident and where it is making mistakes. So here you can see, right, it is making mistakes for these sections, but here it is working fine only. Like we discussed, so see for the jacket denim and all, it is hoodies and panjang, it is behaving correctly only. And then we also did a noise robustness test. So if we look into our code, so here, 1 minute. So here we are also having our noise robustness. So here we added some things like we have resized it, we have cropped it, we added color jitter is like adding brightness and reducing the brightness, and also some blur also we have added to the images. So we are do this and all we are doing to see like if we add some noise to the image, then how our model is and how accurately our model is able to predict. So when we added this section and when we tested, if we see the results here, so we got our noise validation accuracies to 73%. Here, before in our training when we did, we got our accuracy as 80%. But when we added some noise to our image, we can see, right, prediction level has slightly fallen down to 73%. So I added blur and color changes to the validation images. So the accuracy has dropped to almost 74%, but that is fairly still robust only, because when there is some noise in images, the model will like any model will struggle a bit, right? So still we can improve that. That is something we can work in future. And then also I have taken some random images from the internet. So you can see, right, I have taken this final test. These images are not there. So let us say there is sari here. So actually if you look into my data set, I have not trained this model with sari. So here there is a sari photo, you can see. So for this, if you see the output, uh, 1 second. So you can see the output here, right? So I have so this code is basically is like it will take this data set and it will try to give the similar recommended items for this. So even that is also one of the research question that we actually tested here. So if you see here, I have given jacket, so I have got all the images related to jacket, so it is predicting correctly. And if we take this chudidar I haven't trained, so it is taking now, it is predicting incorrectly with overconfidence. Then if you see the next output, I have given as jeans. Again jeans it is able to predict correctly. So on jeans model we saw, right, on jeans it is like 93% it is confident on it. So it is training correct, it is giving correct outputs. Then if we take gown, again gown I did not train, I did not give any no, gown also we have given. So gown, you can see, right, here 92% it is having confidence, it has given all the similar kind of gowns. Next I have given polo t-shirt. So polo t-shirt it is like it is has given slightly so out of one, if I give one polo shirt, here I got only one, rest all are like t-shirts. So it did not predict correct, it is having less confidence here, it is like having only 40% confidence here. And then if you take sari, I have given sari, but in my data set there is no sari, but still it has given wrong prediction. So it is like if you see overall to give the similar items, out of six inputs, four it has given correctly and two it's still lagging. So we have to still improve that. So overall, to summarize, like what we have done, and so we have taken a model, pre-trained model, EfficientNet V2 Small, which is the latest model for image classification, which is having ImageNet as a backbone. And here we have taken our data set, and on the last layer we modified our data set and trained it. So we have given 15 epochs here, and we also can see we have plotted the training loss and validation accuracy. And we could observe that over a period of time of training, our training loss and the validation loss got reduced, and our training accuracy and the validation accuracy got improved. So overall the model has behaved stable for the loss, and the accuracy is also improved. Then we also tested with different kinds of images, adding color jitter and blur and resizing and cropping it. Then we also printed our confusion matrix, like at which class the model is getting more confused, and at which class the model is behaving more accurate. Then we also printed our F1 scores. So this F1 scores tells like which model which class it can predict more accurately. Here we can see that 92%, that is for genes it is able to predict more accurately. Then we also have seen how like how this model, how it has given the top three correct and incorrect predictions. Then we also have taken a random internet images, and we also tested how it is able to predict. Out of six random images here, four it was able to predict correctly and give the with good accuracy.